Hello and welcome. You will now learn about JSON and YAML. These two data formats are commonly used in automated and repeatable deployments. JSON stands for JavaScript Object Notation. Some of the AWS services you use for configuration management support JSON as a data format. AWS CloudFormation is one of them. It is important that you understand the JSON format so you can use CloudFormation. You should be able to understand the structure of a JSON document, because you may want to write some AWS CloudFormation template for yourself. JSON is a syntax for storing and transporting data. It is a text-based format, so it is human readable. JSON documents store key value pairs and arrays of data. The data can be structured so you can store very complex data in a single JSON document. The key use case for JSON is that it supports the simple exchange of complex data between computer systems. You commonly see data in a column format, such as a table. However, to store table data in a way that is easy for machines to ingest, parse, and distribute, it must be stored in a non-graphical way. The example shows that you can store data from a table in the JSON format. Like any standard, JSON has both advantages and disadvantages. One key advantage of JSON is that it is lightweight. JSON has only a few syntax rules you must follow for your JSON document to be considered valid. It is also a good choice for use with APIs. In fact, JSON is a common data exchange format for modern RESTful APIs. JSON is as easy for humans to read, and it is easy for machines to parse and generate. However, JSON also has some disadvantages. It is more verbose because keys will need to be repeated for every possible value in the category. You may also have long files where many lines consist of only an opening and closing curly brace. Another disadvantage of JSON is that it does not have built-in support for storing multimedia formats like images. Consider how you will describe an object, such as the dessert shown here. What properties does it have? 4 properties that describe it are highlighted. Here's an example of how you can store the properties in a JSON object. The JSON object has 4 properties that describe the cake. You enclose JSON objects in curly braces. There are also a few rules for JSON data structures. First, a JSON object consists of an unordered set of key value pairs. You separate the keys from the values with colons. All keys and values are enclosed in quotation marks. Key value pairs in an object are separated with commas. The last key value pair does not require a comma after it. In the example, the flavor key value pair could come before the type key value pair. The object will still be considered valid by a program that receives this JSON object. If you want to be more specific about this dessert, you could add additional properties. For example, if the cake was made with blueberries and mint, you could include this data in the JSON object. When you want to describe a property with multiple possible values, you add an array to the JSON object. Here, an additional ingredients array was added to the JSON object. Arrays are formatted differently than key value pairs. To define an array in JSON, you enclose it in square brackets. An array in JSON is an ordered collection of values. Unlike the key value pairs at the root of a JSON object, JSON arrays are ordered, so you can parse them by index value. The very first element of the array has an index value of 0. Array values can be strings, numbers, objects, Boolean values, or other arrays. The example array has 2 values, both of which are strings, that is, blueberries and mint. However, in longer, more complex JSON documents, you often see arrays that contain other JSON objects or even other JSON arrays. Some AWS services also support YAML as a data format. Later in this module, you will learn about AWS CloudFormation. AWS CloudFormation supports the YAML format as well as JSON. You should be able to understand the structure of a YAML document as well. You may want to write some AWS CloudFormation templates in YAML for your own business. YAML was originally going to stand for yet another markup language. It ended up being called something different. Like JSON, YAML is a syntax for storing data. It is text-based, so it is human readable. YAML documents are easy to write. They store key value pairs, lists, and arrays of data. You can store very complex data structures in a single YAML document. Compared to JSON, YAML is optimized for readability. The same data that is stored in JSON takes fewer lines to store in YAML. This is because YAML does not use braces, and it uses fewer quotation marks. Another advantage of YAML is that it natively supports embedded comments. Finally, many people find it easier to debug YAML documents compared to JSON documents. With JSON, it can be difficult to track down missing or misplaced commas or braces. YAML does not have this issue. Despite the many advantages of YAML, JSON offers some unique advantages. First, it is more popular and widely used. Because JSON is so common, you can use it with many systems without needing to transform any data. AWS CloudFormation supports templates written in both formats, JSON and YAML. The first thing you should know about YAML syntax is that it uses whitespace indentation to describe and create data structures. You must be careful to avoid using tab spaces when you create or edit YAML documents. 2 whitespaces is the standard indentation. However, the document will be valid as long as your indentation approach is consistent. To add a comment, you use a # at the beginning of that very line. You also need to leave a blank line both above and below any comments. To create a list, start the line with a hyphen and write only one list item per line. Alternatively, you can define an entire list by putting multiple items on a single line. However, to use this list structure, you must surround the list in brackets and use commas between the items. To create an associative array, use a colon followed by a space. Like JSON, YAML documents store key-value pairs. They define a single key-value pair using a colon between the key and the value. And you need to use one item per line. Finally, unlike JSON, strings in YAML are normally not enclosed in quotation marks. With that said, you may sometimes see them enclosed in double or single quotation marks. Usually, quotation marks are used to escape characters that appear in the string that will otherwise confuse a system that is reading the YAML document. The examples here show the same configuration information documented in both JSON and YAML formats. The JSON version has more characters and includes many quotation marks, braces, and commas. The YAML version has fewer characters and uses indentation with whitespace, not tabs, to create parent-child relationships between pieces of data. The JSON file uses braces to indicate that both type and properties are children of the web server parent. The YAML file uses whitespace indentation to indicate both type and properties are children of the web server parent. Notice the difference in how the key-value pairs are documented. In YAML, the key and the value are not in quotation marks. The end of the lines do not have commas. The JSON format has many positive attributes, but one of its disadvantages is that you might edit your way into a syntax error that you can't easily resolve. If you remove one brace early in a JSON document, you could spend a little bit of time trying to find the source of the error. Using an editor that's compatible with AWS CloudFormation or JSON Aware simplifies the task of editing templates. Similarly, YAML documents must be carefully written by keeping spaces in mind. You can install the AWS Toolkit on Visual Studio or Eclipse, and this supports editing AWS CloudFormation templates. The toolkit adds supports for AWS CloudFormation syntax highlighting to both editors. Look into the details of the editor you use for AWS-related syntax highlighting packages or plugins. We just reviewed the syntax for both JSON and YAML. This knowledge will help you understand and explore the features of AWS CloudFormation. Thanks for watching.
Welcome. You will now learn about AWS CloudFormation. The cloud opens up many possibilities. However, it also raises questions about how to manage its power and flexibility. For example, how do you update servers that are already deployed into a production environment? Or how do you consistently deploy an infrastructure to multiple regions? There are several ways you can implement automated and repeatable deployments. With AWS CloudFormation, you define a single template file, either written in JSON or YAML. This template file creates a collection of AWS resources together as a single logical unit. We'll discuss how CloudFormation works and how to use it to create and manage your AWS resource deployments. With AWS CloudFormation, you create and provision AWS infrastructure deployments predictably and repeatedly. You can use AWS CloudFormation on services like EC2, Amazon EBS, Amazon S3, and many others. You use a template file to create or delete collections of resources, managed as a single unit known as a stack. If for any reason something changes outside of AWS CloudFormation, you can use drift detection to identify which stack resources have configuration changes made outside of AWS CloudFormation management. Then, you can update the resources so that your stack is synchronized with their definitions in the stack template. Resolving drift helps ensure the consistency of your infrastructure and the success of your stack operations. Two major terms for AWS CloudFormation are templates and stacks. A template is a specification of the AWS resources to be provisioned. A stack is a collection of AWS resources that were created from a template. You can provision a stack many times. When you provision a stack, charges incurred from using these services start accruing when these service resources are created. When a stack is deleted, the order of deletion is determined by AWS CloudFormation. You do not have direct control over the order of when resources are deleted. The most important section of the CloudFormation template is the Resources section. The Resources section is a required section of the template. This section contains the AWS objects you will create. You can create resources across a number of AWS services, including Amazon EC2, Amazon S3, Amazon VPC, and many others. You can specify relationships and dependencies between resources to help ensure that resources are created in the correct order. You can deploy applications, files, and other resources on your EC2 instances with the CloudFormation init command. The init command is similar to the user data section of the EC2 launch mechanism. It enables you to deploy EC2 instances as part of the stack creation process. The wait condition is a special AWS CloudFormation resource that pauses the creation of the stack and waits for a signal before it continues. You can use a wait condition to coordinate creation of resources with other configuration actions and external stack creation procedures. Parameters is an optional section of the template. They are name-value pairs that represent input values. These values are then used in the stack creation process. Mappings is another optional section of the template. They represent keys associated with values that specify conditional input parameters. You can use mappings to refer to the values of AMI IDs in a region. This is because AMI IDs change from region to region. They also change over time when new AMIs are released. Mappings can also be used with other resource IDs that change from region to region, such as EC2 key pairs, subnet IDs, and Amazon EBS snapshot IDs. With mappings, you can repair the values that could potentially break if you run the template in a different region than where it was created. Outputs is an optional section of the template. The Outputs section returns string values created by the template that might be important to users. For example, say that you created an EC2 instance that functions as a public web server. You can choose to output the DNS name of the server in the Outputs section. AWS CloudFormation Designer is a visual tool for creating and modifying CloudFormation templates through a drag-and-drop interface. You can add, modify, or remove resources. The underlying JSON or YAML is updated automatically. If you modify a template associated with a stack, you can update the stack so that it conforms to the template. If you encounter an error when you launch an AWS CloudFormation template, all resources are rolled back by default. You can change this option from the command line. AWS CloudFormation is designed so that all stack resources are created or deleted appropriately. Because CloudFormation treats the stack resources as a single unit, they must all be created or deleted successfully. Otherwise, a rollback takes place. Stack creation or deletion is treated in an all or nothing fashion. You can preserve an EBS volume by setting its delete on termination attribute to false. You can preserve a resource by setting its deletion policy attribute to retain. Some resources might not be deleted when a stack is deleted, such as an S3 bucket. You can also optionally enable termination protection on a stack to prevent all resources from being deleted. You can use the optional parameters section to customize your templates. You can use parameters to input custom values to your template each time you create or update. Here's a parameter with the logical name VPC-CIDR. The logical name must be unique throughout the entire template. Here are the data types supported by AWS CloudFormation parameters. There are also parameter types specific to AWS. These parameters can be useful. For more details, search for parameters section structure in the AWS documentation. After you define a parameter in the template, you can reference it by using the ref intrinsic function. When you use ref, AWS CloudFormation uses the parameter's value to provision the stack. You can reference parameters from the resources and outputs section of the same template. Here's an example that defines a parameter named keyPairName. Later, this parameter is referenced in the resources section of the AWS CloudFormation template. In this case, the data type of the parameter is AWS EC2 keyPair keyname. When you decide you want to create a stack from this template, the AWS Management Console renders a drop-down list with all the key pairs in the account. You must select a key pair from this list before you create the stack. Sometimes you might want to refer to a specific value in a list. In these cases, you can use the fnSelect intrinsic function in the resources section of your template. fnSelect returns a single object from a list of objects by index. In the example, the first value stored in the list of available AZs will be returned. Thanks for watching. See you in the next video. Welcome back. We'll now review AWS CloudFormation mappings, resources, metadata, and weight conditions. Recall that the mapping section is one of the optional sections of the template. A mapping matches a key to a corresponding set of named values. For example, say that you want to set values based on a region. You can create a mapping that uses the region name as a key and that also contains the values you want to specify for each specific region. You use the fnFindInMap intrinsic function to retrieve values in a map. Mappings are typically used to specify different region ID values for the same type of resources, such as AMIs or EBS snapshots. The Required Resources section of an AWS CloudFormation template declares the AWS resources you want as part of your stack. You must declare each resource separately. However, you can specify multiple resources of the same type. If you declare multiple resources, separate them with commas. In this case, two resources will be created, an RDS instance and an EC2 instance. The EC2 instance named Web Server depends on the RDS instance. The database must be created before the applications that run on the web server can use it. AWS CloudFormation sequences some of the resource creation process automatically. These rules change when support for new resource types is rolled out. To ensure a consistent sequence of resource creation tasks, it is a best practice to use the depends on keyword. This is how you specify that AWS CloudFormation should wait to launch a resource until a specific different resource has been created. In this case, the EC2 instance will not be created until the database has been created and has reached a steady state. Use the AWS CloudFormation init resource type to include metadata on an EC2 instance for the CFN init helper script. If your template calls the CFN init script, the script looks for resource metadata that is provided in the AWS CloudFormation init key. You can run and install packages, manage groups, write files to disk, run commands, and enable or disable start or stop services in your EC2 instance. As far as AWS is concerned, an EC2 instance is ready to use when it passes its status checks. However, passing status checks might not mean that your instance is ready in terms of installations and configurations needed. For example, your user data and scripts might still be running commands to install the software needed to turn your instance into a database server. You must use a wait condition to signal to AWS CloudFormation that your instance is truly ready. Think of a wait condition as a stop sign. It prevents your resource from being marked as complete by the CloudFormation template until it receives a code that resource creation is finished. The wait condition handle is a textual representation of the wait condition in your script in order to signal to AWS CloudFormation that your resource creation has completed. Your initialization code is responsible for calling the CFN signal command. The CFN signal command indicates the task was successful. Then, AWS CloudFormation will either begin creating the next resource in your stack, or it will mark your entire stack as completed. You can also mark that the task failed. By default, AWS CloudFormation will then roll back any resources it created while running the template. The example template on the left defines an AWS CloudFormation wait condition handle. This resource is named Web Server Wait Handle. A little lower down in the JSON snippet on the left, a wait condition named Web Server Wait Condition is also defined. It waits to receive input from the wait condition handle. The code block on the right includes the user data section of an AWS EC2 instance resource. Notice that it invokes the CFN signal command. It also has a reference to the Web Server Wait handle. After the user data script finishes running, the wait condition handle is fulfilled. Here's an example of the output section. The DNS name of a load balancer defined in the resources section is returned. The URL of the website available through the load balancer is also returned. You can see outputs in the Outputs tab of the AWS CloudFormation page after you create the stack. You can also retrieve outputs programmatically if you run the template using the AWS CLI or the API. The default behavior of AWS CloudFormation is to roll back all changes when a stack fails to successfully complete all actions. You can override the default. You can also apply a stack policy to prevent updates to stack resources. When you create a stack, all update actions are allowed on all resources by default. This means that anyone with stack update permissions can update the resources in the stack. You can prevent stack resources from being unintentionally updated or deleted during a stack update by using a stack policy. The policy determines what action to take if stack creation fails. You can set the action to do nothing, roll back, or delete. You can specify either on failure or disable rollback, but not both. In the example AWS CLI command, you can see that the create stack command is being run, and the default rollback on failure option was overridden. Instead of rolling back on failure, AWS CloudFormation does nothing. Any resources created by the failed stack will be left unchanged. You can also prevent a stack from accidental deletion by enabling termination protection on the stack. If a user attempts to delete a stack and you enable termination protection, the deletion fails. The stack, including its status, remains unchanged. Both stack creation and stack rollback can fail. In the case of a rollback, you can instruct CloudFormation to continue the rollback even after the rollback has failed. Some common causes of a failed rollback include changing a resource in your stack outside of AWS CloudFormation, insufficient permissions, limitation errors, or resources that are not stabilized. A stack goes into the update rollback failed state when CloudFormation cannot roll back all changes during an update. For example, you might have a stack that is rolling back to an old database instance that was deleted outside of AWS CloudFormation. After you remedy the cause of the failed rollback, you instruct AWS CloudFormation to continue rolling back the update. For more information about rolling back an update, search for Using CFN Updating Stacks in the AWS documentation. Thanks for watching. See you in the next video.